Welcome to the webinar on partial discharge measurement on power cables in order to avoid any unplanned outages. So the agenda of this presentation and this webinar will be that we will discuss about some basic of partial discharge theory. We will show some structure of the power cable, the technique to detect and locate partial discharges, the sensors which we use for online partial discharge measurement, and Qualitrol offerings on online partial discharge measurement, and some of the interesting case studies which will show the high noise environment and show the challenges when we do online partial discharge measurement. So about the partial discharge theory, according to IEC 6270, it's a localized discharge which happens in between the conductors, near the insulation, or inside the insulation, or near the conductor. So based on the location of that defect in the insulation, on the insulation, or near the conductor, there are different types of partial discharges. If the defect is inside the insulation, then it will become an internal discharge. If the defect is on the insulation of power cable, then it will become surface discharge. And if there is a stressed region because of some protrusion, some impurity near the conductor, then it will lead to corona discharges. And if internal partial discharges keep on happening in the cable insulation, it will lead to electrical trees. So for online partial discharge measurement, the two most important types of defects or the types of partial discharges in the power cables are internal partial discharges and the surface discharges. So this is a little bit theory about
Amar,
why partial. Yes.
I'm sorry. We're having a hard time seeing your slides progress.
Okay. Is it updating?
No. Maybe take it out of slideshow mode and put it back in. There we go.
Oh.
I see it. Great.
All right. So sorry about that. So I was talking about the types of partial discharges, which will include internal partial discharges, the surface discharges, which are the most important when we are performing online partial discharge measurements. So it's good that you reminded me, because this was one of the most important slides to actually define partial discharge. So anyways, so if you have a partial discharge or if you have a defect in the cable insulation, so here we are representing a void type defect. So this is the basic, the very basic simple structure of the power cable, where you have the conductor in the middle, you have the insulation screens over the conductor, and then you have the sheath which is grounded. So this is representing the internal partial discharge. So as the high voltage appears on the conductor, so there will be voltage on the conductor. So because of the field of this high voltage, there will be an induced voltage on this cavity or this type of defect. So this is the voltage on the cavity or the defect because of the presence of high voltage. Because we have now got an impurity or non-uniformity in the cable insulation, so this type of defect will have its own breakdown strength. So as voltage builds up on cavity, it may discharge at certain inception voltage. So as soon as it will discharge, it will release its energy into different forms of energy. And whenever this voltage which is built up on the impurity, whenever it discharges, it gives partial discharges. So because of the its exchange with different forms of energy, it exchanges into electrical pulse currents, dielectric losses, some light, noise, which is acoustic, some changes in the pressure, and some chemical reactions. To perform online partial discharge measurement, we are relying on electrical pulse current to detect and locate partial discharges which are traveling along the length of the power cable. So now let's define and let's actually explain a little bit about the cable structure of the cable network. So whenever cable is manufactured, the design life of the power cable tends to be around 40 years. But because of rapid degradation or because of bad workmanship, cable circuits or the accessories fail before this duration. And the technology which we are presenting for online partial discharge measurement can be used to detect PD in XLPE, EPR, PE, and PILC cable. So these types of power cables can be tested with the help of online partial discharge measurement. And here we are showing a of the power cable where you have conductor strands in the middle. Over the conductor you have semiconducting or the insulation. Means you have the metallic sheet. So this metallic sheet is normally grounded, or it is grounded using SVL at the termination point. So anything which happens in between the conductor and the metallic sheet, if there is any impurity, any type of defect in the cable insulation or the conducting layers, or if there is some impurity, it will lead to partial discharges. And depending on the location of partial discharge, it can be either internal discharge or the surface discharges. Before performing any online partial discharge measurement, it's really very important to know the cable circuit. Excuse me. So in a cable circuit, we have the terminations at the ends of the power cable circuit, and these terminations can be connected to other assets which can include transformers, GIS, rotating machines, or the overhead lines. And different sections of the power cable can be connected with the help of joints. So in a long cable network, and if it is a transmission network or the distribution network, at the grounding at the joint location, there can be solid grounding of this ground at the joint location. And if it is a transmission network, so there can be cross bonding. So the reason of doing grounding and the cross bonding is to avoid circulating currents in the power circuit. And if you have the circulating currents, it will lead to the overheating of the power cable. So whenever cable transmission network cable is laid out or designed, or the circuit is designed, these cross bonding links are placed at different joint locations to minimize the effect of circulating currents or the induced current which travels along the cable earth, and then it actually increases the cable temperature. So to perform partial discharge measurement, we need to access the individual cable earth shield, and we can place sensors around the cable earth or near the termination, and we can detect partial discharges which are traveling along the length of the power cable. But one thing which is very important to note here, that this type of circuit which you are seeing on the screen, it has cross bonding links at both joint locations, and the cable is grounded at both ends. But in a circuit where you have a solid grounding at the joint position, so what will happen if you are measuring partial discharges at this point and you have got partial discharge in this section? So partial discharge will be an electrical pulse current which will travel along the length of the power cable, but it will be grounded at this grounding position. So if you are measuring partial discharges here, you will not be able to see any partial discharges which are traveling from this section towards this and this, because all of the partial discharge which will be generated here, it will be grounded at this joint position. So that's why it's very important to perform, whenever we perform online partial discharge measurement, it's very important to know the cable earthing scheme, or sometimes it's called as cable grounding scheme. So whenever you are doing online partial discharge measurement, there can be a scenario where the remote end of the power cable will be open and it will be grounded with the help of sheath voltage limiter. Sometimes it's then joint 1, then joint 2, and termination 2. In this way, you will be able to perform zoning of partial discharge. So you cannot accurately locate partial discharge. You will be able to detect partial discharge, and you can know that you have got a partial discharge which is higher in this section. So this is the least which you can do with the help of distributed PD monitoring. So a little bit theory about the detection and the location of partial discharge. Now we are going to start. So suppose there is a defect in the power cable. So whenever you have a defect, there will be electrical pulse currents. So there will be two pulses of equal magnitude will be generated from the defect side. So these high frequency current pulses will be generated from the defect side, and they will be traveling along the different towards the different ends. So the pulse which comes directly towards the measurement end. So measurement end means that here you have the sensors and you are recording partial discharge. So the pulse which comes directly towards the measurement end is called as the main pulse, and the pulse which is generated from the same defect side, it travels along the length of the power cable. It gets attenuated in its magnitude, and then it comes back towards the measurement end, and the time difference between the main and the reflected pulse will give you the location of partial discharge. So the idea of detection of partial discharges is to have the sensor on the cable earth shield, and it will be actually detecting partial discharges which are traveling along the length of the power cable. And whenever partial discharges travel along the length of the power cable, they get attenuated. So here, if you are measuring partial discharges, so up to 5 kilometers, you can measure partial discharges. If there are no middle grounding, you can detect partial discharges while staying at the end of the power cable. But obviously, if there will be a very small partial discharge which is just starting in the power cable, it will not be detected, because there is a chance that a smaller magnitude pulse will not arrive at the end of the power cable. But if you keep on monitoring partial discharges regularly or continuously, then you will be able to detect partial discharges whenever it is in the detectable range. And in order to locate partial discharge, the methodology which we use is very famous and called as time domain reflectometry, or the very famous word which is TDR. So it depends on the arrival time of the main pulse and the reflected pulse. So the time difference, which is the delta T between the main pulse and the reflected pulse, will give you the location of partial discharge from the measurement end. And in order to locate partial discharge very accurately, you need to know the cable length, the accurate cable length, and the PD pulse propagation speed, or sometimes it is called as the cable return time. So the definition of cable return time is the time taken by the pulse from measurement end to the remote end and then back to the measurement end. And this will give you the PD pulse propagation speed if we are taking into consideration the accurate length of the power cable. So now a little bit argument about online partial discharge measurement and what's the importance of performing online partial discharge measurement. So most of the defects in the cable insulation or due to bad workmanship, most of these defects give partial discharges. And if you are monitoring partial discharges regularly or continuously, you will be able to detect, and in best case you will be able to accurately locate partial discharge along the length of the power cable. And if you are able to detect partial discharge well before time, you can go for the planned outage, and it will save a lot of cost of unplanned outage. And when you do online partial discharge measurement, there is no need to de-energize the cable system. It is a non-destructive testing. We will not be overstressing the power cable. We will not be applying any external voltage. Cable will be operating under normal conditions. And if we apply the technology in the correct way, and by this means that if we know the cable grounding scheme, then we can accurately detect and locate, or in the second case, we can zone partial discharge along the length of the power cable. And if you are monitoring partial discharges regularly or continuously, then you will be able to know the trend of the partial discharge and you can define the severity of partial discharge. If you get a partial discharge which is staying constant, then it is not an imminent threat. But if someday partial discharge has started increasing and its trend is increasing, then it means this is going to break down the cable insulation, and that can be used as a point where you will take the cable shutdown and perform the corrective measure. And obviously, by knowing partial discharge location or by knowing that which phase of the partial discharge you have got, you can go for a planned outage. And the last point is very important. So on the repair of the termination or the installation of new termination or joint, you can perform online partial discharge measurement regularly or continuously to confirm that this joint or termination is defect free. So you can actually confirm the good workmanship, or you can actually detect the bad workmanship done on the joint or termination. So the sensors which for online partial discharge measurement include high frequency current transformer. So this sensor is used to detect partial discharges which are traveling along the length of the power cable, and this sensor is used one per cable earth. And along with this sensor, we use transient earth voltage sensor, which is used to detect partial discharges which are happening at the termination of the power cable. So high frequency current transformer, there will be 3 HFCTs which will be detecting internal partial discharges, while transient earth voltage sensor will be detecting the surface discharges which are happening at the termination point. Instead, you can use 3 high frequency current transformers and the noise antenna to perform the noise gating in the software. So whenever there will be an external pulse on the noise sensor, then that will be gated out automatically in the software. So there are different locations where you can place high frequency current transformer. One of them is on the individual cable earth shield or over the cable by passing the earth shield back. For this scenario, you need to know the load current or the power frequency current of the cable. So and according to that, you will be able to use the correct sensor. So we have different variants of high frequency current transformer, and the maximum of one can go up to 1000 ampere of the power frequency current, and the maximum diameter 150 millimeter. The sensitivity of the sensor goes up to 10 millivolt per milliampere, and the frequency response is from 200 kilohertz to 15 megahertz. And along with this sensor, as I mentioned, we can use transient earth voltage sensor that can be placed near the termination point. So if there will be some surface discharges happening here at the termination point, it will be detected by the HFCT and transient earth voltage sensor. So you will know that this type of partial discharge which is happening at the termination, it is the surface discharge because it is being detected by the transient earth voltage sensor also. Otherwise, you can use RF antenna if you want to perform noise gating if there is external noise which is being detected by the system. So here are some of the examples of the placement of high frequency current transformer. On the left, you can see there are 3 high frequency current transformers on the individual cable earth shields of 220 kV cable termination to GIS. On the right side, again, another example. Another example where you have HFCT on the right on the individual cable earth shield, and on the left you can see the example of sensor along with HFCT. So the methodology of performing online partial discharge measurement is that you need to access the cable earth shield, and you can place the sensors over the cable earth or near the cable termination, and these sensors will be connected to the portable or the continuous monitoring solution with the help of sensor cables, and these systems can monitor partial discharges regularly or continuously. So from the Qualitrol side, we can perform online partial discharge measurement, and we give following services So first of them is the field service. In the field service, we can perform the site survey and the feasibility of online partial discharge measurement. If there is any risk involved, we can do the risk assessment, and we share the methodology of performing online partial discharge measurement. And on the average, 6 to 9 cables, 3-phase cables can be tested per day. And then after the test, report will follow up and we will give our recommendation and findings about the site survey. Apart from this, we offer the portable system. So here, which is in front of you, this is the standard kit where we have on the left is a main unit, and on the main unit you can place the laptop which is provided with the system. So this expert analysis software is installed on the laptop and the data acquisition and the analysis is done on the laptop. And this portable system is fitted with the filters, protection and acquisition card all inside this box. So it can be very good to transport the box at different sites. And on the right side, you have a box which include all the signal cables, sensors, and any accessories which will be delivered as a standard delivery. So apart from the portable system, we have the sensors which will be given as a standard delivery. So you have high frequency current transformer, as I mentioned earlier, that we have different variants, and these depend on the internal diameter, its current rating, and the sensitivity. So we have 4 different variants. So the smallest one is the most sensitive one, while the biggest one has the maximum withstand of the power frequency current. And we have one transient earth voltage sensor that can be used to detect surface discharges. So if you want to, before I jump into the continuous monitoring solution, if you want to get detailed information, obviously we can have a different webinar on the portable system and the features of the portable system, and you can contact Qualitrol to have a separate one-to-one webinar or a global webinar on this topic. Now, for the continuous monitoring solution, the technology remains the same. You have high frequency current transformers and you have transient earth voltage sensors which will be connected to the remote acquisition unit, which we call as RAU. So remote acquisition units are placed near the cable termination, and you can have maximum of 9 HFCT and 3 TEVs or 3 noise antenna connected to the single remote acquisition unit. And you can have multiple of these remote acquisition units in the substation. All of these RAUs will be talking to the central server, which will be placed in the control room, and this server will be capturing all the data which will be sent over Ethernet, fiber, or copper. And the central server is responsible for the storage of the data, generating the alarms for IC 61850, and it has UPS which will be able to operate it if there is a power failure inside the control room. And you can access the central server using IC 61850 client, or you can use Qualitrol on software, which is the remote client, and you can visualize different graphs and different partial discharge activities on all the RAUs which are connected or configured for the server. Here a little bit of the screenshot. So on the server software you can have the graphs of the trends which are lasting for the last month or the last year or for one day, and you can see the PD or the non-PD events, and at the same time, apart from the maximum amplitude, you can see the discharge rate on the graphs. And in this way, by seeing the trend of partial discharges, if there is a gradual trend or if there is a constant trend which is not increasing, then that's a safe. And if you see gradual increase in the trend, then it means this partial discharge activity has become activated and it will lead to the failure of cable insulation. And some of them you can see for each of the recording, you can see the detailed categories. So the best case or the beauty of this software or the monitoring system is that whenever it performs a recording, it categorizes every recording. So here this recording you have only one type of category. if there will be different partial discharge activity or different noise signals, so these will be categorized separately. So you just need to click on each of the categories. You can see whether this is a partial discharge. Obviously, system is classifying everything by itself. So for the confirmation, you can see from the pulse shape and from the phase resolve activity, you can confirm the partial discharge activity. And again, I'm going very quickly and just giving the overview of the portable system of field service and continuous monitoring solution. If you want to have a detailed webinar, we can also do that. So whenever you have, as you have the experience with online partial discharge measurement, or you have gone with some experience, or if you read the literature, so the only biggest challenge for performing online partial discharge measurement is the external noise or the system noise which is present inside the system. So here I will be presenting some of the case studies which will help you to understand how we are separating out different activities and how we are classifying as partial discharge or the noise. So the first case study is very simple. So we had the lab verification of the technology where we introduced different types of signal. So this was the cumulative, which is showing all the activities. So in this lab verification, we introduced a real partial discharge on the power cable. We had some random noise and we have some repetitive noise. So and all of these signals were happening at the same time, and then the analysis was performed on the recording. So when the analysis was performed, all of the activities was repetitive noise, the real partial discharge happening on the power cable, and the third one was the random noise which we were introducing at the same time. So all of these three activities were separated out confidently. And these are the three separate categories which I was talking about when I was explaining the continuous online monitoring solution, that the system can separate out different activities. The real side story where you have 220 kV cable termination connected to GIS and the other end of the power cable was connected to overhead lines. So this is just for your information, just for the example. This was just cycle data. Obviously you will not see such graphs in the software, but this is just behind the scene to let you know what is happening when we do online partial discharge measurement. So if you analyze this graph, this is just a single cycle where you have the background noise of going up to 100 millivolts, and you have big pulses going up to 4 millivolts. So the system acquires multiple cycles, performs filtering, and then perform the categorization and then artificial neural network to confirm whether we have got a partial discharge or a noise. So from the same data, which you can see is very noisy, so from the same data categories performed, and on the channel A, one of the category, if you see its phase resolve pattern, it looks partial discharge, but if you see its pulse shape, this is not a partial discharge. So the characteristic of a partial discharge is that you will be seeing a transient pulse, shaped pulse, if you want to confirm whether this is a partial discharge or not. So there's one criteria is that it should be transient shaped or spike shaped, and its phase resolve pattern should be phase consistent. It should not be random. So this was one of the activity which was a noise activity in that data, and from the same data, this was the partial discharge pulse which was extracted by the software, and this was the phase resolve partial discharge activity. So this is the example where you have huge noise and system was able to detect partial discharge and extract that activity out of that noise. So the last case study which you are seeing here is the example of 1300 meter cable length around 10 kV is actually a 10 kilovolt cable network. So we were performing partial discharge the high connected near the cable termination. So again, this is just a single cycle of data where you are seeing bigger pulse, and if you are just relying on the magnitude, oh, I have got a partial discharge, but this can or this cannot be partial discharge. It depends on the actual analysis. But on the same cycle, you are also seeing some smaller pulses here, which at this stage we cannot confirm. But you know, after performing the filtering, categorization, and the analysis on the recorded data. Different categories were separated out. So this was one of the category which was separated out by the system. And again, if you see its pulse shape, it is oscillating. There is no transient behavior. And if you see its phase resolve pattern, it looks like a partial discharge, but because both criteria are not met, so this is not a partial discharge activity. However, on the same channel, this was a partial discharge activity which was extracted out of the data, and this was its phase resolve pattern. So this partial discharge was activity happening on channel A, or the phase A of the power cable, and the same type of activity was happening on phase C of the power cable. And here you can see the difference in the pattern. Although the pulse shape looks same, but these were different in phase resolve patterns. So in this way, I mean, the main essence of providing all these case studies is that even in the presence of huge noise and a lot of interference, we are able to extract out different activities confidently, and we can perform artificial neural network, which is done automatically, and it classifies between partial discharge or the noise signal. And then we can also, I mean, obviously this is not the scope of this webinar, but we can have the detailed webinars talking about how we accurately locate, how to confirm whether this is a partial discharge activity, or some detailed information on the individual systems, which include the portable system or the continuous monitoring system. We can have it later on. So thank you very much for your time. So now we can take questions, and I think I have passed 5 minutes as per my scheduled time.
It's okay, Amar. So we do have a question regarding, I believe it was one of the slides in the beginning of the presentation. Is it true that water trees do not give advanced warning with PD?
Yes, actually this is a very good question. So the water trees are formed because of the impregnation of water in the cable insulation in the presence of field. So when these trees are filled by the water, they will not give any partial discharge in the power cables. So what will happen, but there is another argument. If you read the literature, if you read different research papers, there is an argument that when these water trees are dried out, these can lead to partial discharges. But one thing we need to actually note down here is that water trees, when these are dried out and they start giving partial discharges, these will be transformed into electrical trees very rapidly. And as soon as you have electrical trees in the cable insulation, it will lead to the failure in the cable insulation or breakdown in the cable insulation very rapidly.
Great, thank you. Are there any other questions to the audience? Please use the chat functionality or the question functionality, and we're happy to answer anything at the moment. Any questions for Amar? All right, well, in the meantime, we'll do our little raffle here. I'm just using a Google random number generator here. So let's see, number 22. So we have Timothy Mentor at les.com. So you are the winner of the swag bag. So if you would like to private message me your information, I'll be happy to mail that out. In the meantime, if there's any other questions, we'll stay on for another 5 minutes. Oh, here we go. Is cable PD system integrated into the Smart Sub platform?
So cable partial discharge is a different platform, and if you can see that it has a different technology and a totally different amount of data which we are getting from the power cables. So that's why we have kept it as a separate platform till now, but it can be integrated into the same server. So if you have an existing GIS transformer PD monitoring solution from Qualitrol, so you can integrate the same system for partial discharges in the power cable. So you can integrate the same RAUs at the cable terminations and you can connect it to the server, but you will have a different software platform for online partial discharge measurement in the cables.
Okay, thank you. Okay, so we have a question. There are many other intelligent-based diagnostics available in literature and is an obsolete method now. It is very limited capability for estimating diagnosis, in particular with the FAP propagation learning technique, fuzzy logic-based and support vector machines. Classifier techniques are more useful and easy to implement. Can you please comment?
Yeah, actually, it's all you are all talking about the neural network technology or the support vector machine or the fuzzy logic technologies to classify between partial discharges or the noise. But from Qualitrol perspective, we have been using artificial neural network for our others expert analysis systems, but for the cables, as you can see that we are only discriminating between the noise or the PD, partial discharge activities. So far we are confident with the same technology and we are getting very confident results when we are, and the reason for that is I would like to mention that, as I mentioned when I was talking about our continuous monitoring software or about the case studies, that we do categorization, and after performing categorization we perform the classification. So we do not perform any classification on the noisy data or the data which also has the noise. And because we have separate categories, separate phase resolve categories for each of the activities, so our artificial neural network analysis works great on this system and you will have very confident, obviously I cannot say that you will have 100% accurate result, but we have very promising results with that neural network technologies. But obviously it depends from different implementation to implementation, and we use a lot of features which are extracted from the pulse shape and from the phases or patterns. So we use a lot of features to perform the final classification analysis. So it really depends on different types of technologies which are in the literature, and everybody is claiming their own algorithm, and I'm not rejecting their algorithm, but the thing is whatever we are doing so far we have very good and promising results coming out of our analysis.
Great, thank you. Any other questions? Okay, any comments regarding possibilities to accurately locate PDs?
Yes, as I mentioned earlier in our slides, so if you have a single network where there are no T-joints, where there is no middle grounding in the power cable network, so you can actually accurately locate partial discharge by measuring partial discharges at the end of the power cable. And for that you need to know the exact cable length, and also apart from that you need to know the PD pulse propagation speed. So we can, I mean, if you contact us later on, we can actually give you the literature or discuss with you in detail how to perform this return time measurement and how to accurately get the PD pulse propagation speed. So based on these two information, the cable length and the propagation speed and the time difference between main and reflected pulse will give you very accurate location of partial discharge from the measurement end. But if somehow you have middle groundings or you have T-joints, then you need to access each cable or shield at different joints position so that you will be able to zone partial discharges in different sections of the power cable. That is the maximum you can do if you have middle grounding or the complex T-joint networks, which normally happens in the distribution network.
Great, thank you. Any other questions for Amar? I'd like to thank everybody for joining the webinar, and please look in your inbox for the recording and the presentation. If you have any questions and you'd like a follow-up webinar, or you'd like to conduct any sort of educational-based activities at your organization or with your team, please reach out to info@qualitrolcorp.com. We're happy to help. We're happy to put those on at free of cost. And if you have any questions, Amar and I will stay on board here for another couple minutes to help answer those. But otherwise, I hope that everyone has a wonderful day, and we hope to hear from you soon. Thank you. All right, Amar, it doesn't look like there's any other questions. Thank you so much for your presentation, and I'll talk to you soon.
Thank you very much. Thanks, everyone.
Thanks.
Bye-bye.
Thanks.